Are our previous assumptions about the development of the universe still valid? The James Webb Telescope has now detected a whole series of objects that should not actually exist in this form. These include, in particular, inexplicable galaxies that existed just a few 100 million years after the Big Bang, and yet already had a mass that is normally only reached after billions of years. And then, of course, there is the Methuselah star, whose age is estimated at up to 15.36 billion years. But how is that even possible when the cosmos itself is only 13.8 billion years old? Could it be that the universe is actually much older than we thought, and that it may not have been created in the much-cited Big Bang after all? Today, we'll show you why the discoveries of the James Webb Telescope have triggered a full-blown astronomical crisis, and why we've been trying to find explanations for the impossible ever since. Whether you're interested in space exploration or not, everyone has heard about the much-heralded launch of the James Webb Telescope. No wonder, since those responsible never tire of emphasizing that the $10 billion device is one of the greatest technical marvels in human history. But what does that actually mean in practice? Well, to get a feel for Webb's unparalleled capabilities, take a look at the following example. If you were to place a bumblebee on the surface of the moon, the telescope would be able to detect the heat of the tiny insect from Earth. With its 6.5 m telescope mirror and 4 infrared instruments, Webb is the largest and most powerful space observatory ever built. And in some cases, it's 100 times more sensitive to electromagnetic waves than its scientific predecessor, Hubble. Designed specifically for infrared astronomy, Webb uses its remarkable power to examine the first luminous objects and galaxies that formed after the Big Bang and the subsequent Dark Age, and to overturn virtually everything we thought we knew about the evolution of the cosmos. After all, what good are the most elaborate theories and comprehensive models if Webb shows us that they simply do not correspond to cosmic reality? When a discovery made by the Space Telescope is so unexpected and confusing that it plunges experts into a deep crisis of expertise and forces them to make the following statement: "We have discovered the impossible." Even the greatest geniuses in history are not immune to error. After all, a certain Albert Einstein initially clung so firmly to the idea that the universe was a static, eternally existing construct that he added a cosmological constant to his field equations. However, after the creator of the theory of relativity realized that the cosmos did indeed have a beginning and has been expanding continuously since its creation, he removed his constant, and is even said to have later regretted this as the greatest blunder of his life. In the aftermath, however, the cosmological constant was reintroduced to explain the accelerated expansion of the universe. And yet, despite all the discarded worldviews and U-turns, there seem to be things that are literally set in stone. After all, the majority of researchers still agree that the universe came into existence around 13.8 billion years ago in the Big Bang. Contrary to the official description, however, this process does not describe a violent explosion into an existing space, but rather the rapid expansion of space itself from an original singularity. Matter and time also emerged from this tiny hot starting point. But how can we possibly know that today? Well, it's quite simple. We just have to look backwards at the development that Einstein initially denied, namely, the expansion of the universe. In this way, it's possible to calculate backwards to a point where the density of matter and energy is infinite, and all spatial distances are zero. The proof of cosmic microwave background radiation is considered outstanding evidence for the correctness of the Big Bang theory. This relic from the time shortly after the Big Bang is almost isotropic and fills the entire universe. And apart from these fundamental assumptions, another assumption states that the first galaxies that formed shortly after the Big Bang should have been small. According to the astronomical consensus, the first stars existed just 200 to 300 million years after the birth of the universe. But exactly when these stars formed star clusters and the first galaxies, and how quickly they grew, remains a mystery. The only thing that is certain is that experts have identified several galaxies in the images taken by the James Webb Telescope that existed just 300 million years after the Big Bang. And as expected, they turned out to be small and low in mass. However, the 6 early galaxies that were discovered shortly afterwards threw the previous model into complete chaos. Although they are of a similar age, they are already almost as massive as our Milky Way is today. Astrophysicist Evolab, who was part of the research team that analyzed the images of the galaxies, described his initial reaction to the groundbreaking discovery as follows. I ran the analysis software, and it spat out 2 numbers: distance, 13.1 billion light-years, mass, 100 billion stars. I almost spit out my coffee. I knew we had just discovered the impossible. Impossibly early, impossibly massive galaxies. Why these galaxies shouldn't exist at all. Together with his team at Swinburne University of Technology in Melbourne, Lab analyzed several images taken by the near-infrared camera from the James Webb Telescope's early release program. The images show a section of the sky near the Big Dipper, which had already been studied by the Hubble Space Telescope and is commonly considered part of the dawn of the universe. During their detailed analysis, the experts finally noticed a series of striking, reddish-shimmering points of light whose characteristics indicated a great distance, and consequently, a great age. Using redshift, the researchers concluded that the light took more than 13 billion years to reach our eyes on Earth, and that it therefore originated from objects that existed just 500 to 700 million years after the Big Bang. Further characteristics of the points of light indicated that we are dealing with 6 very early galaxies. But instead of the predicted baby galaxies, the scientists were confronted with fully grown galactic giants that exceeded all expectations. The data revealed that all 6 early galaxies have more than 10 billion solar masses of stars, and that one of them could even be approaching the 100 billion solar mass mark. But how is that even possible? According to our current knowledge, there simply wasn't enough normal matter at that point in time to form so many stars in such a short period of time. Well, to explain the existence of these galaxies, either the matter density in the early universe must have been 2 to 5 times greater than our models predict, or the galaxies must have formed in a way that is completely unknown to us. Either way, scientists find themselves in a real dilemma. Both cases require a profound change in our understanding of the evolution of the universe. And if anyone knows what such a profound change in understanding might look like, it's Rajendra Gupta. After all, the astrophysicist from the University of Ottawa and his team came to the following groundbreaking conclusion. The universe could be twice as old as we thought. But how did scientists arrive at such a conclusion that contradicts our established assumptions? Well, on the one hand, we must not forget that the 6 early galactic heavyweights were ultimately only the beginning of further, similarly confusing discoveries. Since then, Webb has brought several other galaxies to light that also appear far too massive for their age. These include the so-called Big Wheel, whose discovery was announced a few weeks ago, and which, with an almost monstrous mass 5 times that of the Milky Way, is larger and older than anyone had previously thought possible. But that's not all. In addition to the early galaxies in astonishingly advanced stages of development, we also know of HD 140283, a star that appears to be older than the universe itself. Located in the constellation Libra, the age of this stellar Methuselah is estimated to be between 13.66 and 15.36 billion years. But doesn't that render the discussion about the true age of the universe moot anyway? After all, if we have detected an object out there that is demonstrably 1.5 billion years older than the cosmos, it's beyond question that something must be wrong with our Big Bang theory. Well, one might think so, but we shouldn't be too hasty. In this case, the crucial point is measurement inaccuracies. Researchers say that a 30% inaccuracy must always be assumed. This means that 70% of the star's age lies within the determined spectrum of 13.66 to 15.36 billion years, and 30% does not. In fact, more recent calculations even suggest that the celestial body could actually be significantly younger. But despite all this, Rajendra Gupta and his team of researchers came to the conclusion that the universe was not formed 13.8 billion years ago, but 26.7 billion years ago. More specifically, the Ottawa researchers focused on the current theory of redshift, which forms the basis for determining the age of the universe. However, The authors of the study criticize this theory for not taking into account the so-called coupling constants. These are fundamental physical constants that determine the interactions between particles, and which may have changed over time. If the models allow them to evolve, the time frame for the formation of early galaxies observed by Webb at high redshifts can be extended from a few 100 million to several billion years. According to Gupta, this makes it easy to explain the confusingly advanced development of early galaxies. After all, they would have had significantly more time to form. In the same breath, however, Gupta also proposes a reinterpretation of dark energy, which is commonly believed to be the driving force behind the accelerated expansion of the universe. And lo and behold, other new research findings now actually suggest the compelling conclusion that this mysterious force is not constant, as previously assumed, but that it has been weakening for some time. This once again reinforces the evidence that our current picture of the cosmos has massive gaps, and that we are still a long way from fully understanding our cosmic home. Not quite as far away, however, is the subscribe button below our video. Please click on the thumbs up and subscribe now to never miss a new post from us again. We'll see you soon.